Good afternoon, good evening, and good morning for those who joining us around the world. My name is Sahan Abeysekara, and I would be your moderator today for the BS Group online conference, Ballast Management System Installation. Before we start, I will just give you a brief overview of today's agenda and how we're gonna conduct this conference. So we have today 5 more panelists, including myself, is going to be 6, who presenting various subjects around ballast water treatment system. I'm actually glad that we have a very good representation from different stakeholders today. So it will be expecting for a very fruitful discussion for the next hour and a half or 2 hours, let me say. So after the presentation, we will open up for the Q&A session. But if you have any question, please use your Q&A button and send your questions. So at the end of the presentations, we will go to these questions and we will try to answer as much as questions as we can. And the other questions, if we have time, we may be able to give you some contact details so you can ask that questions directly. So with that, I think it's time for us to start the conference. And first is going to be my presentation. What I'm trying to do is to give you an overview of the regulatory and compliance update with the ballast water management system installation. With that, I hope that it will make a good start for the other panelists to discuss their respective subjects. Okay, let me share my presentation. Right. Okay. So going back with the, as I mentioned earlier, my presentation is about ballast water management system, regulatory and compliance update. With that, I will start with the application of the convention, which ships needs to comply with the ballast water management convention. Ballast water management convention applies to all ships, including submersible, floating craft, FSCU, FPSOs. And the convention also states, it's not, as I mentioned in my presentation, ships that warships or ships that running in the under one jurisdiction, and the ships that have permanent ballast water in seal tanks, which you don't discharge ballast water. And also, the convention allows you to have exceptions and exemptions from the ballast water management requirements. So these exceptions are situation specific, whereas the exemptions most likely to be granted well in advance. Also, the convention provided administrations to allow equivalent compliance, especially for ships such as pleasure craft and or recreational craft, expedition vessels, rescue vessels, which are less than 50 meters in length and have a maximum ballast capacity of 8 cubic meters. So when does the ship need to comply with the Ballast Water Convention? Ballast Water Management Convention entered into force on 8 September 2017. From that day onward, the ships either have to comply with the ballast water exchange requirement, which we call regulation D1, and subsequently, or after that date, if it is a new build, ballast water performance standard, which is regulation D2. I must stress that the complying with regulation D2 performance standard, there are many ways you can do it. But within the context of this conference today about the installation, we are focusing on the ballast water treatment, which is the most popular way of complying with the regulation D2 standard. And the ships, all ships above 400 GRT needs to have an approved ballast water management plan, ballast water record book, and to be surveyed and issued with International Ballast Water Management Certificate. So there are still some administration who has not ratified the Ballast Water Convention, so they may be able to issue with a statement of compliance instead of the International Ballast Water Convention certificate. Let's move into the next slide, which we are going to talking about the ballast water compliance schedule. So we know that the ships, if you choose to install a treatment system as a compliance method for regulation D2, when your ship needs to install a treatment system and comply with the regulation D2. So all the ships have it after the enter into force of the date of the enter into force of convention, 8 September 2017, be required to fit it with a treatment system at delivery. So for the ships constructed before 8 September 2017, they need to install a treatment system with the compliance schedule in accordance with their IOPP renewal survey. This is a cascade way of installing. So because to reduce the to actually prevent overcrowding of the capacity for ballast water installation. And if I go to the next slide, this will explain you when your ship needs to install a treatment system based on your previous IOPP renewal survey. Now there is a bit of a confusion because the Ballast Water Convention itself refers back to IOPP renewal survey, which the IOPP renewal survey is not actually part of Ballast Water Convention. It is part of MARPOL Convention. So what I wanted to tell you here is that the IOPP renewal survey is mentioned in the convention just to give indication which date or from which date that you needs to comply with the regulation D2 standard. Otherwise, there is no direct connection between MARPOL Convention and the Ballast Water Convention. As I mentioned earlier, the Ballast Water Convention applies to all ships. But if you noted in my previous slide, I mentioned about the IOPP renewal survey and the compliance schedule. One thing we have to be careful with is the MARPOL Convention only applies to ships above 400 GRT. So this schedule is basically for the ships above 400 GRT. But there are ships under 400 GRT or ships that IOPP renewal survey does not apply. For those ships, ballast water performance standard should be met by a date that is decided by the respective flag administration, but not later than 8 September 2024. Another important things to consider when you are installing treatment system is about this date, 28 October 2020, which is not very far from next month. The ballast water treatment system to be installed on ship must be approved in accordance with the Ballast Water Management Code, or what we used to call the 2016 guidelines, or we call it revised G8 guidelines. And this is a very important point because especially with the COVID situation, there is a little bit of uncertainty whether there is enough treatment systems available which has ballast water code approval or the revised G8 approval, which probably we can discuss in the QA session. So the next slide, I wanted to discuss about the process of how to get the International Ballast Water Management Convention compliance certificate for your ships. So the ships, you may already have a International Ballast Water Management Convention certificate under Regulation D1 for Ballast Water Exchange Standard. And from the day onward that your ships needs to comply with the Regulation D2 standard, you need to have a type approved system installed on your ships, and the installation should be in accordance with the manufacturer's recommendation, and you need to follow their advice. And there are certain requirements in the ballast water code that how the installation should be. And then your ballast water management plan of your ship, which has maybe regulation D1 exchange standard mention, needs to update, including the ballast water installation, ballast water treatment system, which is regulation 2 and approved by the flag administration. And then when you have this documentation and the systems available installed, the ship's flag or recognized organization, classification society maybe, on behalf of the flag, will conduct an initial survey for the Ballast Water Management Convention to certify the ballast water installation. So this is the process where you will undergo in order to issue the ballast water management compliance certificate for the regulation D2 standard. Now, very recently, there was another requirement. It's an operational test following installation needs to be conducted in order to complete the initial survey. So this is what we call a commissioning test. So you need to do a commissioning test and take a sample of your discharge water, analyze to see whether it's compliance with the discharge standard. And that is complete the requirement to conclude the initial survey and subsequently issue the certificate. Now, I wanted to discuss a little bit more about the commissioning testing because there is a lot of confusion in the industry regarding the commissioning testing. Who should be doing the commissioning testing, how you should do it, and when. So let's get into the commissioning testing. Remember the purpose of the commissioning testing, it's to validate the installation, saying that when you have this installed treatment system to see whether you install correctly and it is operate correctly. So this is very clearly mentioned in the Ballast Water Circular 70 commissioning testing guidance. And this commissioning testing is not intended to revalidate the type approval test of a treatment system. The type approval testing is separate. It's been type approved, it's been certified as a unit. What we are doing is that when you bring that unit in different components and install in your ship in accordance with your layout, in accordance with the space requirement, to see whether that installation is conducted properly and the system is operating properly. So for the commissioning testing, there is no specific challenge condition requirement, unlike for the ballast water treatment system in terms of number of organism for uptake or any physical or chemical water composition. But you have to be careful where you going to do the commissioning testing, because you have to take into consideration the system design limitation of your treatment system. For example, if you have a say electrochlorination system which require certain salinity to operate, you cannot expect it to be commissioned on a water where you have a lesser salinity than that, maybe on a freshwater river, etc. So you have to be careful with that. And often we see the commissioning survey, the commissioning testing will be done at the yard where you do the installation. And for any reason, if you can't do the commissioning testing on that, you can't complete the commissioning testing on that place. For example, maybe your treatment system that you are choosing may have a different holding time requirement. It may need a couple of days of holding time to comply with the type approval conditions. Then your ship may move into another place. So the commissioning testing may not be able to complete at the same place, which is okay. What you need to do is to inform your class society or RO through the class society to the flag, and then they will provide you with a short-term certificate until you go to the next port, and then you can complete your commissioning test requirement. So the commissioning testing, again, to consider as a successful completion of commissioning testing, there are two parts. One is the sample and analysis, as you mentioned earlier, of your discharge water. And the second one is assessing the self-monitoring parameters for their correct operation. So I have listed here few information that what a self-monitoring parameter would be for a different treatment system. This is a non-exhaustive list, of course, but whoever's conducting the commissioning testing need to make sure that they identified the correct operational parameters and then assess those during the commissioning testing. That brings us the next question: who can do the commissioning testing? So there is no hard and fast rule, but it mentioned in the revised commissioning test guideline that the sampling should be independent from the manufacturer. You can imagine that this is an exercise that once you fulfilled, your ship will be issued with a statutory compliance certificate. So any party that could be with conflict of interest of getting that certificate, our advice is should not be part of the commissioning testing. And the second part is whoever is doing this commissioning testing, most probably a service provider, needs to have a understanding of the marine biology. They need to know how to do a sampling, and also they need to know about a bit of information and the experience of operating a treatment system, not just an operation, but to understand what are the system design limitation, what are the operational limitation of that particular treatment system, and how they assess the self-monitoring parameters. So for example, from Lloyd register, we would expect the service provider, we actually approve the service providers under Lloyd Register's LR approval service provider scheme. So we audit the service provider to see whether how qualified they are, how skilled they are. Do they have a track record? Do they have a quality management system that they can perform these duties? And then we allow them to do the commissioning testing on LR class ships. The reason for that is, if I go back to the next slide, the biological testing for the purpose of the commissioning testing can be of analysis can be of using an indicative equipment, which is very easy to use. You don't need to have great skills or experience of using that equipment. However, when you're taking the samples has to be taken in accordance with the regulation G2 guidelines, which is exactly similar to type approval testing. So whoever is doing that sampling needs to know how can they take a representative sample without inducing mortality to organism to represent the actual scenario of the ballast water discharge. And as I mentioned, the sample can be analyzed using indicative equipment. You can also use a detailed equipment that is more onerous and it's more accurate than the indicative. It's not a problem. But as I mentioned earlier, the service provider needs to know, have an experience on conducting the analysis and also the self-monitoring parameters. And once you have completed the commissioning testing, that will conclude the initial survey, and the RO or that surveyor will be able to issue the International Ballast Water Convention certificate to that particular ship, including the regulation D2 guidelines. So this more or less conclude my presentation. The next slide, you will find the LR dedicated website for Ballast Water Convention requirement. There are a lot of documents there, a lot of information that you will find useful in there. So please visit. And we are providing a lot of solutions to different stakeholders. When you go to website, you will see that. So if you wanted to contact us, all the contact details will be there. And we are glad to help you in your journey getting the ballast water installed and certified. So this is concluding my presentation. I think we can move into our next panelist. That would be Shobit Agrawal. And Shobit is the project manager for AP Moller Maersk. Shobit, is back to you.
Thank you, Sahan, for good introduction and great overview of the ballast water management conventions. Just allow me a second. I'm going to share my screen, and please let me know once you are able to see. Are you able to see my screen now?
Not yet, Shobit.
Okay.
Yeah, it's coming up now.
Yeah. Okay. Yeah. Thank you, Sahan, and we'll take it up from here. So good morning, good afternoon, and good evening to everyone. Welcome to today's session on ballast water management. I'll be speaking about the topic how to choose a right ballast water management system for a ship, which is one of the key decisions to make, as the ultimate goal is not only limited to the successful installation and commissioning of the system, but also for the successful and smooth operation of the system for the life of the vessels. Yeah. So my agenda during the presentation will be starting from the introduction, the considerations which are required for the selection of ballast water management systems, identifications of the stakeholders, the availability of different treatment technologies, the makers list, and will at the end touch base upon the cost part. So myself, I'm Shobit Agrawal, working with Maersk for last 5 years, and it's close to 3 years since I am associated with ballast water treatment system project as a project manager. I have a sailing background and last sailed as a chief engineer with total 11 years of sailing experience on different types of vessels. Moving ahead, the would like to start with the considerations for the selections of ballast water management systems. As you know, there are many variables, internal and external, which governs the decision of suitable ballast water treatment system of the vessel. So it's very important for us to have a very good understanding of the vessel's systems and the vessel's operations. To begin with, we need to know what's the vessel's trade pattern. We need to identify the length of the voyages which the vessel has been doing or is expected to do in future, the duration between the voyages as it governs the holding time of the treatment systems, whether vessel is operating in fresh waters or brackish waters, and the regions of operation, whether it is cold or tropical. Then we need to identify what has been the vessel's cargo loading and the unloading pattern, as that governs the ballasting and the deballasting operations of the vessels. We need to work upon the vessel's ballast pump systems. We need to go through in detail, understand what has been their ballast pump capacities, how has their piping system been set up, and then the one important factor which comes and plays a very key role is the what's the current status, because it's not necessary the drawings which will follow exactly the same way. So it could have been that the pumps have been old and they are not performing up to their design limitations. So yeah, we need to check on their existing status, and maybe it's required to upgrade or overhaul those pumps. Then the age of the vessels, which will determine uh, for the remaining life of the vessel where we are going to have this system in place. Another key factor is not only the capital expenditure which we are going to have after the during the installation of the treatment systems. It is one more important criteria. What we have to look is the operational expenses which we are going to incur during the remaining life of the vessels. So it is one of the key parameters is the ballast volume, which will help us in identifying or calculating these operational expenses. And the other support could be we get it from the running hour records from the vessels of the ballast pump. Yeah, the various design limitations are with regards to like power, the availability of the power on board, the space, the control and integrations systems, the tank structures, coatings. And as you know, the installation of a ballast water treatment system varies from ship to ship. It could be inside the engine room, it could be in the pump room, on deck, or as a containerized solutions. But whichever location is being selected for the installations, or we need to check and confirm the temperatures at those areas, the vibrations, the ventilation systems, lighting systems, and the maintenance area sufficient is available for the during the operations of the system. Yeah. Yeah. Moving ahead, the stakeholders, identification of the stakeholders. As you know, there are many stakeholders which are and will be involved in this project and also impacted going ahead. So it's very necessary to have their valuable feedback from the time to time and from beginning as well. Stakeholders vary for different owners and different management companies. So it is good to identify them well in advance and keep them informed as well as have their inputs. So as we are set up in a mosque, there we have a project team who is executing this project, which is in the central and executing the project, and with the help of an engineering company. So they are the ones who are assisting us in designing the retrofit of the ballast water treatment systems. So it could be an in-house company for different owners, or it could be an third-party companies. Definitely the makers of the ballast water treatment systems, the classification society support for the approvals of drawings, as well as during the installations their and commissionings their approvals, the yard and the or the installations team if it's being done through during the sailing, and some other stakeholders like the finance teams, the supply chains, for the connections of these to the different shipyards and different vessels, the naval architects for reviewing the structures, the vessels, electrical teams, the superintendents, fleet groups, and these are to name a few. Yeah. Moving ahead, we'll like to give a brief on the different treatment technologies available, as there are a variety of technologies are available in market for treatment of ballast water on ships. Many of them already have their necessary approvals, and some of them are under process. Each technology has their own constraint when it comes to availability of space, level of environmental friendliness, cost effectiveness, or the skill required for operations. Some of the technologies available have more than 2 decades of experience in the marine industries. and it becomes equally important for us to understand these technologies available and to match with the vessel's requirement. A typical ballast water treatment system on board ship uses a combination of two or some in the cases single technologies to ensure that treated water is in compliance with the IMO standards and or the USCG standards. So to name a few, starting with the first five technologies, if you look at it, are the ones where we are having two treatment technologies, starting with filtration plus electrolysis, filtration plus electrodialysis, filtration plus ultraviolet, and filtration plus chemical injection, and the pressure vacuum and ultraviolet technologies. Then the later on, the below technologies are the single technologies which are effective in getting the treated water as per the compliance standards like electrolysis, heat, ozone, chemical injections, acoustic, electric pulse, and the magnetic field treatment. Yeah. So once we very well understand the requirements of the vessel and zero in on the technology which we is suitable for the vessels, we have to identify the makers for the vessels. So, as there are many makers available in the present market, and to begin with, we need to verify on the certification status of the makers, and which, as Mr. Sahan just mentioned, the various approvals and the new regulations which is coming from 28th of October 2020. So it is very much important to have their verification on the certificate status. And as you, the best source to verify this, I believe, is the IMO portal, where they update on a regular basis the list of the approved ballast water treatment system makers. And similarly on the portal from the USCG, where they keep on updating regularly the various approved list of makers, as well as those makers which are under review. At the end of the today's webinar, this presentation can be shared where you would be able to access those links if required to go through them in it. Then the one of the other important area to look is the service networks, because as the vessels can be trading worldwide, so it is very prudent to have a service available anywhere, as anything can go wrong, and it's very important to have the availability of the service engineers at a short notice. So it's good to have a worldwide service network in that scenario. Yeah. And yeah, moving ahead, would like to touch base upon the cost which is being uh, uh, there on the during the executions of the project. So as we can see, the of the major two of the major chunks of the pie are the cost of the equipment, which varies from 40 to 45%, and the installation cost, it varies 40 to 60%, and these are the figures which we have seen in the past, but it can vary much more than that as well, because it will depend on the location of the installation. It could be in the shipyards, or it could be during the on sailing and through the installation team on board. So it varies from case to case basis, but this is just for rough idea estimate purposes. Then the next is comes the engineering cost, which are in somewhere in the range of 6 to 7%, and the integration cost 3 to 5%. Although from the cost perspective, these two costs are not very significant, but what we would like to highlight here is the time required in these two jobs are comparatively much more, and it's very prudent to invest or spend a lot of time in here, so that we can have a very well designed system for a vessel, so that there are less and less challenges for the vessel crew to operate, and it could be made more and more simpler and convenient for the crew to operate. Then yes, it comes the approvals from the classification societies for the various drawings as well as for the plans. Then it so a small part of it also is the training, but it needs to be done in advance and during the installation as well, because it plays a key role in successful operation of the systems. So nowadays there are many mediums of training, starting from a computer based training to visiting the ballast water treatment system makers, their site where they have systems up and running. And it could be during the commissionings and during the arrangement of the service engineers while uh, sailing. So yeah, so this is a brief overview on the cost. Yeah. So yeah, that's all from my end. And in the end, I would like to conclude that selecting a right ballast water treatment system for a ship requires a very good planning, and it's a time-taking exercise. So it has to be done precisely, and we can have a very good treatment which can be successful and easy to operate for the vessels. Yeah. That's all from my end, Mr. Sahan. Thank you.
Thank you, Shobit. Thank you very much for very informative presentation. As you mentioned that planning is key, I think, when you going to install a treatment system. Without that, you can be in big trouble. So moving into our next panelist, this would be Mr. Gregory Papadakis. Gregory is the managing director of the Papadakis Shipyard brokers. So back to you, Gregory.
Good afternoon to all of you. Sorry, I don't have a presentation and a point system, but I'm an old-fashioned, and I was very, very busy selling water ballast systems. So I will just you have to bear with me with my speech. Because as you know, the Greeks are the last ones to install the water ballast systems. The Greek owners, they managed to get extensions, and they managed to delay the installation of the water ballast systems as long as possible. This is very clever because now the prices are very low, much, much lower than what it was 5 years ago. And the technology has been improved the last 5 years. So the Greek owners, they have the advantage by delaying the installation to get water ballast system, very low price, and at the same time, they have checked around the systems, the various systems, so they know by speaking to their friends what system is the best, what system is the more efficient and economical to operate. So now most of the Greek vessels will install the water ballast system in 2021, 2022. This does give them really a very good advantage. First of all, prices. Second is the third generation or fourth generation of the system. The filters have been improved. The documentation and the certification has been relaxed or has been concluded. So I'm dealing with the Greek owners, which are very, very difficult. The Greek market is the biggest, but also the most difficult. The Greek owners, they want the lowest price, but at the same time, the best system. The owner is discussing the price, the technical manager is discussing the system. So you have to convince both the actual owner that your system is the lowest and good value for money, and the technical people that the system that the boss decide to buy is efficient and is operational. My company is shipyard brokers for the last 32 years, but also I represent water ballast systems and scrubbers, plus all other technical services like spare parts and repair teams all over the world. I do not represent a system exclusively, because when I decided last 10 years ago to deal with water ballast systems, I didn't want to tie myself with a system that after 5 years will be proved to be not efficient. So you can say I'm a freelancer, So, and I look around, I see what system is the best, and I recommend the system to my customers. The last 10 years, I have installed about 250 water ballast systems, various shipyards in Turkey, in Singapore, in Spain, in Greece, all kind of vessels from VLCC to Handymax. At the end of the day, I have come to a conclusion that there are some systems that they have advantages over the other systems, or they have the technology that they use, it's more efficient than the technologies or more economical than other technologies. I saw before that one of the presentations in the various technologies, in the list was not the electrocatalysis system. Many technical people or others, they confuse the electrolysis with the electrocatalysis. That's why electrocatalysis was not in the list of the existing technologies of water ballast system. Electrocatalysis compared to electrolysis has a very big difference. For example, for electrolysis, you need the salinity of the water to be very high. For electrocatalysis, the salinity is very, very low, 0.85, when the fresh water is 0.5, the fresh water in the lakes, and in the oceans is 55. So having a distinction between electrolysis and catalysis, automatically you have a system that can operate in all seas, including the river bands in China, plus the North Europe, everywhere. Only, let's say, in lakes in Canada, you may have to add some seawater in order to increase their salinity. But even this seawater that you have to hold is very small, because from 0.5 to increase it to 0.86 is very small amount. Another difference is that the power consumption of electrocatalysis is very low. To give you an example, for a system that is operating a pump of 1,000 cubic meters capacity pump, the power consumption is 17 kilowatts per hour. For a big system like 4,000 cubic meters is 150. That's very low. So when it comes to the Greek owners, you do not ask them if the diesel generators are efficient or good, or they have a capacity of 80%, because they say maybe today they have 80%, but maybe tomorrow will be reduced to 65. So I need a system with low low power consumption. Also, if you tell me the pattern of your vessel, so I give you the right system, they say, my vessels are working all over the world. Today they're in Atlantic, next year maybe in the Pacific, or they may go coast to coast. So must be a system that is cheap to buy, is cheap to operate, have no side effects, and easy to the maintenance, and also to have after-sales service. A lot of manufacturers in the brochures, they have a list of offices that they have after-sales service all over the world. But most of them is just an address. If you actually call them and say, I have this problem, can you solve it? They will ask you to call the manufacturer. It might be Chinese, it might be Korean, lack of language, lack of time and time difference. And this will make a small problem to come to a big problem. Having a manufacturer that it has in a big market like in Greece, like in Singapore, like in Germany, they own after-sales service and to be 24 hours operational, it really makes the technical manager more relaxed. And it really solves problems that can be very minor, but if you don't solve them then, it might cost a lot of money to the owner, as the vessel may be waiting in America to go into the port and cannot get in because the system doesn't work. Then they need Saturday, 5 o'clock in the morning, an answer. An answer because one alarm is ringing and nobody knows from the crew what is the problem. The manual that the manufacturer is producing and it gives to the technical people and also to the crew is also very important. A manual which is only 10 minutes but doesn't give details of how the crew to solve some small problems or how the crew to change the filter elements because they went to muddy waters in the rivers and the filter, although has a backflash or whatever, is still not operational, is very also important. So a manual that is detailed and is very understandable and is in simple words and has a lot of samples of the various problems is also important for the owner and the technical manager. Training. I would like to see a manufacturer to gather the customers and the technical managers that they have bought the system, to gather them once a year and to explain to them the problems that may occur or what the difficulties they may have or how to train the crew. This is also important. But coming to the actual advantage of the electrocatalysis, I'm not going to say what system or what the maker of electrocatalysis is the best of the best because it's like advertising myself. And that's not my view because the reference list is one good advertisement. It's very important the TRO level. The TRO level is the indication of how often you have to change the pipes of your water ballast system and how often you're going to use the neutralization unit. Using the neutralization unit very often costs money and also takes time. There are some systems that the TRO, it's only 2 ppm. This means that when the entrance of the ballast water is 2 ppm, very fast and very soon it will be reduced to 0.2 or to 0.1, which is the maximum that the IMO or the American Coast Guard will allow. This is why there are some systems that because the water entering the ballast tanks is also only 2 TRO, within 2 hours of holding time, the water is treated and the water can be deballast and comply with the limitations of the IMO American Coast Guard. This TRO also reduces the damages of the pipes, as I said before, the corrosion, and the operational cost of the vessel. Another element that the owner, the technical manager will consider is the byproduct of the system. If it produces chemicals that is damaging or have to be controlled or detected, it means that you have more alarms and more sensors. So a system that is produces a lot of hydroxide, it must have extra alarms to check it out and to prevent any accidents. Electrocatalysis do not produce these byproducts. So you're saving extra alarms and extra sensors. I said about the power of consumption. To give you an example, the power consumption of a system that is for 1,000 cubic meters capacity is only 17 kilowatts. For 4,000 is 150. The operational cost, how much will cost you to run the system? how often you have to buy spare parts, and how the maintenance. I have a very detailed table that it gives you, if you give me the capacity of your pumps, how much will cost you in a year, 5 years, or whatever. To give you an example, a council mass that with 1,500 cubic meters pump capacity, in 10 years, the operational cost, including fuel plus spare parts or whatever, is everything included, and I have this in details, is $64,000, which means $6,400 per year. That includes the fuel, includes the spare parts, the maintenance, and everything. This is very low, and this is very serious for the owner. It's serious because if the operational cost is low, he's going to use the system. And the more often he uses the system, the more experienced the crews become. So you don't leave the system idle, and then just because you go to America, you have to switch it on and to be 100% operational. You use it all the time because it's cheap. Footprint. When it comes to retrofit, footprint is also important. Also this, although this electrocatalysis is using filters, the footprint is not big. How big depends on the size, and if you're going to install one system in every ballasting pump, or you're going to use one big capacity to cover both pumps, or one pump. Coming to filters, the biggest competitor of the electrocatalysis, because it's well known now to the market that electrocatalysis is one of the most efficient and cheapest systems to run, is that there are some companies now that they produce and they install water ballast systems without the filter. This is, I can say, is something that is a big competitor, because otherwise all the advantages, the electrocatalysis is superior to all the other systems. Doesn't matter what system it is, if it's UV, chemicals, electronics or whatever. But when you come, the owner has an option or a choice to choose between electrocatalysis, which is okay, the best and very reasonable priced, with a system that is without a filter. The technical people are very relaxed. They're very happy to buy this system. First of all, they don't have a filter. With the biggest headache for the technical people is the filter. If the filter is no operational, is no working, then it's a big problem. But even lately, with having a system without filter, the sentiments that the system is collecting or is allowed to enter to the ballast tanks is causing a problem. Soon the regulatory body will make mandatory that the ballast tanks should be cleared and cleaned by all sentiments, and it will be also inspections for this. At the moment it's not mandatory, but it's a recommendation that the ballast tanks should be clear of any sentiments, and also the ballast tanks to have access, so the sentiments all to be approachable and to be able to take them out. So for the time being, having a system without a filter is easier to operate and maybe it's cheaper, but maybe later on will cost to the owner additional expenses as he has to clean thoroughly the ballast tanks. And maybe later on he has also to clean it in such a way that the cost will be enormous and it will be more than having a filter. Anyhow, this remains to be seen. I don't know if I have more time, but I think I said most of the things that, and the questions that I'm facing when I'm visiting an owner, and I try to promote, because he asked me, okay, Gregory, you're not exclusive of any system, but you've been trained for various systems. What system, in your opinion, is good for our vessels? for me, by not being an exclusive agent, I have the freedom to say this is good, this is bad, this is used to be good but not anymore, or this used to be bad but now has improved and has a very big research and development department that I guarantee the efficiency. So, in my opinion, everybody should follow the Greeks, what they are doing. Because the Greeks, we have survived, we have, and thanks to the technical managers, that they succeed the impossible. They succeed to make the owner happy by getting the cheapest system, and at the same time, to persuade or to even improve and to recommend changes on the systems that they come across, so the system to be the best. So then everybody's happy. The owner is happy, the technical people is happy because he can sleep in the night or weekends, and the authorities are happy because they have clean waters.
Okay, Gregory. Thank you very much. Yeah, thanks for sharing your vast experience. I'm really sure that the audience would appreciate knowing that knowledge. So with the interest of time, let's move on to our next panelist. And this would be Nikolas Vaporis. Nikolas is a technical manager for capital ship management. Nikolas, back to you.
Hello, Sahan. Hello, how are you?
I'm very well. Thank you, Nikolas. Hi.
Good afternoon from Piraeus. Let me share. Okay, there have been a lot of talk before me, so I will go fast. I think that the previous speakers have explained in detail the selection of the system. I was asked to focus a bit on the power supply, the salinity, and the tank stripping. This is the list of the systems, not all of the systems, but this is a long list of systems. Why we put this list here is because it happens that in our fleet, in the capital fleet, we almost have experience with systems from every technology family on board our ships. This happened because some ships came as second-hand to us. Some ships were new building retrofits, and some ships actually we had to decide. So all of this is giving us a variety of systems on board the fleet and a variety of experiences, as you understand, operational issues, problems. And I will be happy to take any questions on this later on. As you know well, and as it was described by previous speakers, the operational limitations are very important when somebody is selecting a system. Actually, the Coast Guard describes very well in the certification scheme and the certificates the various limitations, operational limitations like holding time, like a PSU, density. Okay. All of this, as I said, they are described in the approval certificates. We will focus now on power supply, the salinity, and the tank stripping. Power consumption, the people who have worked on retrofits, they have bigger challenges than new buildings. Many times it happens that the power consumptions will lead to modifications in the switchboards. As you know, this is a quite significant cost, and sometimes can lead also to delays in retrofit, especially these days when the logistics are very much restricted by COVID-19. As an example, I will give some data from the public domain for a system of 1,000 cubic meters flow, okay, per hour. For a chemical injection system, the power is very low. It happens that we have such technology on board our ships. For other systems like UV, electrochlorination, electrolysis, the systems are of course more demanding, as everybody knows. Now, a bit comparing the UV versus electrolysis power supply for, again, a system of 1,000 cubic meters per hour. For a PSU of 30, there is quoted consumptions of 20 kilovolts, and this is going up to 100, 105 for freshwater operation. For side streaming, as you can see here, the figures are not significantly higher, but of course there is a limitation of PSU. For some side streaming, PSU is up to 15. Now for UV, as you know, UV systems require treatment in both ways, and this is reasonable to have a bit more power energy. This is from the public domain, as I said, one of the biggest maker of UV systems with a very long reference list. I put this maker here because we have this system on board our ships. And this is the power consumption figures from the Greek maker, First. Now, a bit about the PSU and the port data. When we select a system, as it was described before, previous speakers, it is important to have the limitation of the ports. Of course, whereas it's great to more remote ports, as you know, and this is not an easy exercise. We have many ships trading in the rivers, in Brazil, Argentina area. The list can be exhaustive. But anyhow, through the list, together with the makers and engineering teams supporting the projects to identify all the ports and the limitations of each system and benchmark them all. Some basic definitions. Happens that it's not easy sometimes to read the certificates, especially the Coast Guard certificates. What is the UVT and what is the PSU and the UVI? These are the definitions for the people to go through later on. What I want to focus is the last point, that for electrolysis chamber, when there is a low salinity, or by Nikolas there is a need for additional water, high salinity water. Now, for the people who are very much interested in these systems, due to the size of the ballast tanks and the weight of the ship, the UVT and the UVI factors have to be taken very much into consideration. The makers provide a variety of makers out there selling systems with various specifications. So there is a need of this to be scrutinized very well. This is an example of a certificate, actually, for a UV maker. And as you can see here, IMO and USCG have very much different approval schemes. And the operator has to then decide whether the ships will trade to America, whether there are more limitations or rivers in America, Mississippi, or elsewhere. Water salinity. Water salinity affects the PC systems, as you know, and as it was discussed before. There are systems with very low salinity, can work with very low salinity down to 0.85, as also said before. However, the majority of the systems are certified to higher salinities, and this leads to a need of seawater in a AP tank or other tanks. Of course, the AC systems, they have their standards, and they can adjust the PSU by injecting the salt water. Tank stripping, sometimes this is somehow not looked very much in detail during the selection of the system. I want to focus on the first bullet, that single treatment technologies, i.e. ballasting in tank treatment, do not affect the stripping operation. Of course, as I said before, we have to check the capacity of the pumps, but when it comes to tank stripping, that's more straightforward. And the systems that require two-way treatment, then they have to be looked very carefully. Some conclusions. It is important to understand the system design limitations, especially the US Coast Guard certificates, and this to be discussed with both technical department and the operations department in order to determine the suitability of the system technology. Failure to understand the system design limitations could lead to operational problems, or could lead to actually wrong selection of a system. Also, it was said before, you can have a stoppage of the system, or a longer stays in ports, or need to deballast and ballast again, as it says also here. The EU systems work well for vessels operating in brackish and marine waters, where enough salinity is available and the power need is very low. For vessels operating in fresh waters or low salinity waters, the systems may not operate properly, affecting the performance. There are solutions, but we have to take this into consideration. When operating low salinity ports, the vessels should plan to carry enough salt water or brine, depending on the technology, if it is full stream or side stream electrolysis. Now, when it comes to UV, the high turbidity waters in rivers may affect also the operation of the ship, especially in Shanghai area or other areas like Mississippi. If the UVT is too low, the UV based cannot operate, let's say, as they are designed. There are limitations. Now, this is a statement that I found in one of the classification societies guidelines, and says that an option for vessels conducting frequent ballasting in freshwater ports or high turbidity waters is to conduct sequential ballast water exchange with BWMT during reballasting after departing the port. There's a lot of debate on this. I have discussed with a lot of people. Maybe Sahan can give us can elaborate a little bit more, since this is also a regulatory issue. And the last one is for the power. We also have experience in this company that insufficient power available to meet the ballast system power requirements may lead to different technology selection, causing extra cost, more complexity, and it cannot be avoidable. That's all for me. Thank you very much. I'll be happy to take questions.
Thank you, Nikos. Thank you very much for sharing your knowledge and experience on different ballast water treatment systems. I'm sure we have some few questions when we come into the QA session. We'll move into the next panelist. This is Ms. Urian Barreta. Urian is the Technical Sales Manager for Optimarine. Incidentally, the only ballast water management manufacturer in today's conference. Back to you, Urian. Urian, you're on mute.
So now I'm unmuted, but
yeah, now it's okay.
Can you now see my my screen?
We can see your screen. You need to open the presentation. Yeah, okay.
Yes, well, good morning, afternoon, evening, wherever you are. Nice that you're attending this conference. I will tell you a little bit about the Optimarine ballast water treatment system, which is, of course, my favorite system. Let me see. Yeah, so first I will tell you a little bit about Optimarine, about the design philosophy of the system, how it works, the three main components, then a little bit about options and some retrofit experiences. And I will try not to make it too long. So Optimarine has a very long history. Already in 1994, Mr. Halvard Nielsen started working on ballast water treatment. So Optimarine is actually the oldest ballast water treatment manufacturer. And you can see the timeline. So first there was, you know, this prototype and developing. Then the Ballast Water Management Convention came in 2004. So then there were clear rules. So then the system was tweaked and modified to meet these requirements. In 2009, we had our IMO certification and DNV approval. And then we were the first in 2016 to receive the US Coast Guard type approval as well. And now I'll just move to the actual date. Now is we have more than 850 systems that are sold and more than 500 are up and running. And here you can see a little bit of a map. This is a marine traffic map where you can see the fleet with Optimarine systems fitted. And so I think this is a nice, yeah, it shows you nicely how many systems and that you can actually use them all over the world. So the design philosophy behind Optimarine is that it's done from a seafarer's point of view. So it's not like a land-based UV technology that was then modified to use in marine situations. So we said, okay, it has to be robust and reliable. It has to be modular and compact because it has to fit in an existing engine room. It has to have few components. It has to be as simple as possible. We use high power UV, so that is a downside on this system or on any UV system, but yeah, especially also on the Optimarine system. We use a flow pressure valve to control the back pressure and to always also control the flow in the system. We have really focused on making it really user-friendly, so there's not a long training needed. We also have remote training, computer-based training, and of course onboard training after installation and commissioning, which lasts about like 2 hours, and then the crew can work with it. It has little and easy maintenance, and yeah, 99% of all maintenance is done by the crew itself. So you don't need to have a service engineer on site. We also have remote assistance if needed. And then also we always use high quality components. And of course, as Mr. Papadakis mentioned, is that prices have gone down sharply. which has caused in many makers to choose for cheaper components. And we still stick with high quality components, mostly Western Europe components. So the system, it's a UV system. So then basically you filter the water up an intake. It runs through, let me see if you can see the area. It runs through UV lamps and then it goes overboard. If you do deballasting, you bypass the filter and you only run over the lamps. So there, it is a two-way treatment, but you don't really lose any time on your deballasting because you have to run through the pipes anyway. You don't really have extra resistance or extra, I mean, filtering, of course, can cause a sort of a delay when the system needs back flushing. But on deballasting, yes, you have to run it through the system, but it does not really cause extra time or anything. And there's no neutralization needed or whatever. So the three main components, there is the filter. In our current new ballast water management code, so the revised G8 code, we have two different systems. We have the Filtrex filter, which many makers use, and we also have the Bollenkirch filter. They're now both fitted with a screen type mesh. So the old filter used to have candles, the Bollenkirch filter, but these are now both with a screen basket type. Both filters have a 20 or 25 micron filter mesh. That is due to this more stringent regulations. Both filters are automatic self-cleaning, so it just has a differential pressure. So as soon as the pressure goes up, then it will automatically start to backflush. We always deliver a backflush pump, and that is also from an operational point of view. We just feel that it's important to make sure that the mud can be moved overboard and you don't have any issues there. The system is modular, but each filter comes in different sizes. So you choose the filter that fits the range of your water most closely. And there's a minimum pressure needed of 2.5 bar, so you have proper backflushing. If you have less, then you get more often backflushing. So the UV lamps, each tube contains one lamp, and each lamp treats 167 cubic meter per hour. So if you need a larger system, so for example, this one is a 334 system, this one is a 667, you can also stack them on top of each other, so you have different ways to have a layout. And in case one lamp breaks down, then these automatic valves, they close down automatically, and then you reduce the flow and you can run over the other lamps. So you don't, so there's a certain redundancy in the use of the system. Then that was UV already. The quartz, the lamps and the quartz sleeve, so there in each tube has a lamp, and then the lamp is shielded and protected by a quartz sleeve. And our system, we have chosen to not clean the sleeves with any citric acid or any wiper or any other method. If you run the system through fresh water, you flush it after use, to not fresh water, but just clean, not too dirty ballast water, then the quartz sleeves, they stay clean enough. And you don't need any additional method. If you only run the system in really, really muddy waters, then you need to occasionally take out the quartz sleeves and wipe them clean and then put them back. And the UV intensity meter that is mounted will tell you when the sleeves are getting dirty. And you need to check them once a year anyway. So then there's the flow pressure valve. In the new system, the model is slightly different. It's smaller, but it has the same functionality. And this flow pressure valve always makes sure that you have proper back pressure, so you have a good back flushing. And it also regulates the flow in case you use only one lamp, or if you have a larger system, you use less than all the lamps. So this always regulates the flow and the pressure. I'll just go over this. So then when you do warm up of the system, the lamps always need cooling because they produce a lot of heat. And if they are not cooled, then they will burn quite quickly. It's all automatically secured. So if you run them hot, then the system will shut them down to prevent them breaking. So when you warm up the system, first you will run C to C. So you have your C chest open, and then you run over the lamps straight overboard again until the lamps are in full power, and that takes about 90 seconds. And then the system will tell you, okay, now we're ready to go. And then you move to the next step. You go ballasting. You choose which valves you open, to which tanks you want to ballast. That's of course a choice of the crew. And the system itself regulates all these other valves. So your bypass valve, the system bypass valve is closed, the filter bypass valve is closed. So you run through the filter, then you run through the UV, and then you go overboard. If you start to deballast, you press on the screen, you say, okay, now I want to go deballasting. Then the system will automatically open the bypass valve for the filter and close these two valves. So then you will run past the filter, over the UV lamps, and then overboard. Then you can also connect it to your stripping ejector. This is the vessel's stripping ejector. The drive water is run over the filter. It is not compulsory anymore. You can now, these days, you can run it without filtration, but we always recommend to do it with, because first of all, you have better treatment, and secondly, you keep your lamps more clean and your entire system. So you run your drive water from your general service pump, for example, you run it through your filter, then you go to your stripping ejector, you mix it with strip ballast water, and the mixture is going over your lamps and then overboard. And also that is automated, that these valves will open and close when they have to. The backflush pump will take care of the mud to move it overboard. Well, where can you use the system? We already heard a bit about salinity. Of course, UV is not affected by salinity, and it's also, which I didn't hear mentioned in the other presentations, temperature has quite a big effect on effectiveness of electrochlorination systems. So if you are always running your system in really low temperature waters, you may have issues with your electrochlorination, especially also with the holding time. So, but for UV, of course, that does not make a difference. Also not, it's no temperature, no salinity, doesn't matter. It has full US Coast Guard approvals. So you run it in US Coast Guard mode when you go there, and if you go in other areas, in IMO areas, you run it in IMO mode, and that's just a selection switch on the touch screen. In IMO mode, the power is automatically reduced whenever possible. So Optimarine uses quite a bit of power, which gives it a big range of effectiveness. So you have more areas where you don't experience any issues, because you can just, you have this extra power available, but as soon as you don't need it, it will automatically reduce it. So it will check the UV intensity, it will see, oh, the water is nice and clean here, so we turn down the power. This is a little bit about the difference between the US Coast Guard and IMO. For the US Coast Guard, you need to demonstrate that all organisms are really dead. And with UV, one of the effects of UV is that we saw it in one of the earlier slides already, it affects the DNA. So then the organism is not necessarily really dead, but it cannot reproduce anymore. So, but then in the US, they don't accept that. So they really need a little bit, we need to use more power to make sure that they're actually not moving anymore at all. For the IMO, I already said that the power will be reduced based on UV intensity, and then the average consumption is 17 kilowatt per lamp, which is 17 kilowatt per 167 cube. And for the US Coast Guard, you have to run on full power. Then there are a number of options: fresh water filling, interlock panel, stripping, power management, advanced UV control, OptiLink, and integration into ships' automation systems. I will just go over each one briefly. If you don't use the filter or the system for a longer period, like longer than a week or 2 weeks, then it's advised to drain it and fill it with fresh water, because this 25 micron, of course, is easy to get foul or clogged. So, so then it's an option to have this automated. Then after so many hours, it will automatically drain and fill it with fresh water. And you can always do it manually, of course, but it can be automated as well. The interlock panel can be used if you have a number of bypass possibilities and you don't have a fully automated system. So then for example, I think you can see it in the next slide. If you have an illegal bypass, so in the rules it says if you have any bypass of the system, you need to log it and you need to alarm it because it's not allowed to bypass the system. So for example, if you have these two valves open, then basically your system can just fill like this by gravity, or you can discharge like this, or the other way around, actually discharge like this and fill like that. So you want these alarmed, and if these are not automated, then you can use the interlock panel to connect those signals and also to then say to program the logic. If this valve plus this valve is open, then it should give an alarm. Stripping, we already mentioned that, so I'm not going to go into detail about that. The power management system, since it is quite a heavy consumer, it can be connected to the power management system. So you can choose, you can override other users, so you don't have a conflict of power use. Then there's a advanced UV control. So if you have a very large system, for example, if you have a 2000 cubic meter per hour system, which has 12 lamps, 12 tubes, then you can say, okay, now I'm running only one pump, so I only want to use these 3 lamps plus these 3 lamps, for example. And yeah, in that way you can just choose, you can use part of your system instead of the entire system when that's applicable. OptiLink is an interesting remote method also for our service people. If they are invited by the ship's crew to have a look, then it's like team viewer. So you need to have a login code, and then so we need to have allowance, so to say, to look, and then we can see, and our service people can update the software. They can assist the crew with any issues they may experience. And so that's very helpful also in to have this permanent service available. Apart from that, we have a worldwide network with actual service people that can, of course, also jump on board whenever needed. Most of the time it can be solved remotely, and with some instructions it can be solved by the crew. Not always, and then we have a service person on board. The OptiMarin system is very easy to integrate into an existing ship's automation system. All the intelligence and the logic is inside the OptiMarin system, and then we only need to have a number of input-output signals, and then we can completely run the system from the existing automation of the ship, which is of course most easiest and convenient for the crew. Some retrofit experiences, you can recognize this one as the system that is behind me. This was on a cruise vessel. It's a 500 cube system. Yeah, you see the filter here and then the tubes. This is from the other side. This is the old control panel we have now. It's a bigger screen. It's a little bit more functionality. One of the added functionalities, by the way, is now we have automatic flow control. So as soon as the UV intensity is going down because of poor water conditions, then the flow control will adjust the flow. So it will just reduce the flow down so you can still keep going. So first, of course, it will up the power. And then if that's still not enough, then it will reduce the flow. So you're still in compliance. So with the new revised G8, that's some new functionality that we managed to add into it. There's a containerized design, so that can be useful for yeah, relatively easy installation. I'm not completely convinced of in which cases you would really want to have a container on deck. I would always prefer to have it in the engine room, but sometimes this can be a solution. This is it's an official design. It's not just a sea container that we use. It's a real container that is custom built for this purpose. We've done many installations for different navies. One of them is the Dutch Navy, where they have chosen OptiMarin system for us. I believe it was seven of their existing vessels. Yeah, which is a quality stamp, I think. US Coast Guard actually also chose Optimarin for their new build vessels. So that's also something that we're really proud of. This is a nice example of our first 3D design. This is the design, and here it's actually installed. So yeah, you can see that a 3D design can really help to see beforehand how it's going to turn out. Also, the system can be squeezed in really small places. This is a supplier. You can see the cement tank here, and here the UV lamp is squeezed next to it. And this is also a one lamp system. So this is a 167 cube system with a Filtrex filter, also squeezed in a really narrow, tight space. My personal preference is always to have the system not on a skid, but to have it like in loose components, because then it's easier to blend it into an existing location. You need to do some engineering anyway, because you need to tie into your ballast pumps. You need to have an overboard. So you have to do some engineering anyway, and then you might as well see how you can blend it in an existing space instead of having a big box that you need to find space for as well. This is a big one. It's a 2,000 cubic meters for Saga. Saga is one of our most favorite customers because they have been early adopters and they have chosen to fit their entire both retrofit and new build fleet with Optimarin, and they keep coming back. So they are really happy with the performance of the Optimarin system, which is nice. Cyprus Cement in the Baltic. This one was installed in 2012, and you can see that they operate in really low water conditions. So you need your mud box to take out the ice cubes. That's the only, I mean, that's just to prevent damage otherwise, but they melt immediately anyway. Then we also have some option which can be interesting for some ship owners. We do a sort of a leasing construction where there is an external party that does the financing, and then you sort of, it's a financial lease kind of thing that in 36 months the system is paid for, especially for smaller ship owners that have difficulty to invest in this quite large amount of money. That can be interesting. Let me see. Oh yeah, maybe a little bit about I can go into the summary, but then I have some small other things to say as well. It's robust and easy to operate. It's really easy. Of course, you have to bear in mind that if you install a treatment system on a ship, on any type of treatment system, your ballasting operations are going to be different, because you cannot do it as you did it before, because you have this system in between. That's always with any system. So it is important that also the crew learns how to handle it. So the better they can sort of look forward, plan ahead, the less issues they have with the ballast water treatment system. This is of course all the sales things about Optimarin. We are really nice and we're customer friendly. One thing I want to add is that the holding time, of course, one of the benefits of UV is that in IMO you have no holding time at all, never. And in the US Coast Guard, we now have in the new certificate a holding time of 2 hours. So in effect, that means that you have no holding time because you're never in and out within 2 hours. So that is, I think, also a benefit. And I had a question regarding, somebody asked me, like, what do you think about the speech of Mr. Papadakis in the way that he explained his favorite method of treatment? And
Jurgen, sorry to interrupt you. Can we come back? It's in the Q&A session with the interest of time. Okay. Yeah, there will be an opportunity.
To emphasize a little, okay. Well, then I will just say a little bit about the reason that I have chosen Optimarin as a company to represent and to work for is that I believe in the simplicity of UV. It's just filtration and UV. It's really straightforward. You need no chemicals. You need no storage of chemicals, or you don't need any neutralization. It does take more power than most electrochlorination systems. Although if you are in very fresh water situations, then it will be quite close to UV as well. But anyway, so that is from a system point of view, from a technology point of view, that those are my reasons for having this as my favorite. It's more easy to install. It's you have less electronics issues. I of course have a background in Galton, so so I have seen many installations of different technologies, and yeah, so my favorite would be UV regardless.
Okay, and thank you very much. It's good to have your experience and your insight of your UV and filter treatment systems. Now we are moving into our last presentation for today, and that is going to be Paul Jacob Binns. Paul is the managing director for Peterson Vessel Performance Center, and Paul today also represent Control Union. So it's back to you, Paul.
Thank you. I hope everybody can hear me. And I know we've had long speeches. It's almost the weekend here in the Netherlands, and the guys over at the West, I guess, have a day ahead of him. So I'll keep it short and crisp, shorter than Urian, I think. I represent the Vessel Performance Center, and the Vessel Performance Center is part of Control Union. Control Union actually this week was granted its royalty sign, and that's because we're celebrating our 100th birthday this year. We're active in 70 countries. We're family owned, not listed, and we think long term. We employ about 4,000 staff all across the world. Founded in the Netherlands, and I'm sitting here by the Maas. Turn the screen because otherwise you guys would all see the traffic. Quite annoying. We started this Vessel Performance Center in 2019. We offer compliance solutions to ship owners and managers because we think that they are underserved. We think that ship owners and managers do not get good compliance solutions today. We offer water discharging services relating to VGP as well as IMO commissioning testing. We do drinking water services with Hatenboer. We report and verify greenhouse gas emissions, both for EU MRV and IMO DCS. I think there was a question on that. And then we offer time charters of vessels to help lower fuel costs with an IT solution. So, and this is done, I guess, by the whole group. The Vessel Performance Center that I represent, we're the front end of it, the customer facing side, but the ones delivering the service, some of them are also in the call, by the way, represent Control Union, which is an ABS approved service provider to commission test your ballast water treatment system. Same for DNV. DAX, the German accreditation institution, has certified our greenhouse gas solutions. And we have a large network of laboratories, the largest one of which, TLR, is based here in Rotterdam. We've done more than 100 projects over the last year, mostly VGP, I have to say. Most of them do not just do drinking ballast water, but we also test grey water and bilge water and drinking water at the same time. More than 2/3 of these projects combine all of that. And we've done so in the past over about 40 ports, which represents half of our network. So you could say the other half is still open. And we have developed this solution together with Oldendorf. And when you receive the slides later, you can read the quote, which we're very proud of. On this experience, I will share our learnings. What have we learned? And in essence, in brief, we perform tests along 3 pillars of regulation. All 3 have been mentioned. Type approvals, I think Sahan talked about in the beginning, as well as commissioning testing. We are a US Coast Guard approved independent lab, one of the 7 worldwide. And we have actually type approved many systems, mostly chemical injection. We perform commissioning tests, and as I mentioned, we do so on behalf of ABS and DNV, on behalf of class. and we do discharge monitoring for VGP. These are very different regulations. I don't think that they will ever converge. They will never become the same, but they're all changing quite a bit. So as you know, in November, there will be an update to Circular 70, and likely the microbiological tests included in the current version of Circular 70 will go away. Singapore being one of the 5 flags that has already kind of made this Circular 70 commissioning testing obligatory as a flag, has already excluded this microbiology scope out of its commissioning testing program. VGP will become VIDA. When exactly, we don't know. American politics, highly unpredictable these days, so no clue when it will happen, but it will happen. And perhaps it converges a little towards commissioning testing, but it will never be the same. My view is that it will always remain a bit of a minefield. And in this minefield, what you will see is an increasing and intensifying, I would say, penalty scheme from port state controls that you have to comply. And for this presentation, I will focus on the last 2 services relating to commissioning testing and discharge monitoring. And I think it's important that when regulation intensifies, changes, and becomes more stringent, that you do not water down the requirements that you place on your service requirements, because after you have installed a beautiful system like Jurian's or like Gregory's, unfortunately, it isn't over yet. You are entering a cycle of tests and compliance services that you need to procure that can end up being very costly. And they can be particularly costly because of things that in hindsight you could have prevented. And that's what I would like to just show to you, the learnings from our last year of operations, is that if you choose your service provider for these compliance services well, and you make sure that they prepare themselves in advance, and you make sure that they think with you as a client, as a ship owner, and you make sure that they stick to the rules and don't take shortcuts, actually you can avoid lots of these compliance costs. So if you do that, and this is what we try to do, and this is why we have set up the Vessel Performance Center, you know, actually the hit rate of good tests, good commissioning tests, and good VGP reports that pass all discharge limits can be as high as 95%. And this is not the industry average, unfortunately. So my point to the ship owners and vessel managers is choose your service provider well and be tough on them. And the first thing that I think your service provider should do, which is what we try to do, is prepare. We will not accept a nomination if we don't think it has a good chance of succeeding. And in shipping, unfortunately, there's lots of changes in the schedule, and many service providers start charging if you change your schedule a certain window prior to the intended visit. That is, I don't think, not needed. If your service provider has a good notification procedure and flexibility both ways, all costs can be avoided until there's actually someone visiting your vessel. Then we've seen, particularly during commissioning tests, a lot of flow-related issues. And I like Urian's filters, but there's other ones in the industry also. And this means that upon commissioning testing, we find a lot of flow issues. These you can solve in advance if you prepare. So if you do, before this expensive commissioning tester or class surveyor comes, if you do a proper cleaning of your system and you trial the flow and you measure it, then you can avoid a lot of unnecessary costs by preparing. Also, reading the type approval certificate and asking your crews to read this certificate, it will help. They will read about holding time, and they will make sure that the inspector that comes and does the VGP monitoring, that he only comes if the holding time of the system has been adhered to. And lastly, there's lots of different sampling points that we have seen, lots of them also set up differently. Officially, Circular 70 refers to the G8 regulation for sampling, which requires isokinetic sampling. My word is the sampling point shouldn't kill any organisms. It should be the system. So sampling points need to be isokinetic. Many cases they are not, and many cases your service provider could have checked this in advance. So there's lots of checks in advance that your service provider can do for you that will avoid costs. And by the way, all these checks, they cost zero. Yeah, they cost zero. So make sure that the one providing you with these compliance services, that they prepare well. Secondly, if you work together with your service provider, like we do with our customers, and then together you improve, and together you avoid costs that are not needed. We do that by having periodic reviews on joint KPIs. It's quite normal in other industries, but not so common in shipping. And we have identified that many cases we measure too high TRO values. And this is specifically for electrochlorination systems. And the reason many times is the TRO sensors. And many service providers that will continue the whole procedure of VGP monitoring, even when TRO is too high, which causes a lot of extra costs. So if you have a procedure in place to investigate the root cause of the TRO sensor calibration issue, and if you have an agreed procedure to stop the rest of the costs and the rest of the work if TRO is too high anyway, actually you avoid a lot of unneeded resources. And lastly, many of these tests, including commissioning testing, take place during other activities of the vessel, for example, bunkering, and then scheduling the visit in advance, finding a delegate of the chief officer or the chief engineer. He will be very busy. She will be very busy. You know, that is, if you do that in advance, together with your service provider, it will make sure that the service goes more smoothly. I get a comment from one of my colleagues. He says it's not G8, but G2. Thanks, Kees. And I think actually that this way of partnering with your service provider, I think it's a normal level of service, even with Greek owners, Gregory. Lastly, I think your service provider that provides the commissioning tests, you know, and that does the VGP monitoring, he should stick to all rules, and there should be no way that he delivers a service that in the end proves not to be compliant. So make sure that when you ask a service provider to come and commissioning test your ballast water treatment system, that he is class approved by the class of your vessel. It will create problems if he or she is not. Avoid all kinds of contamination issues. Make sure that the people that do the inspections, particularly for VGP monitoring, that they are trained and certified, ask for that certification, ask for their procedures, so that there's no instance that you get a fail on your ballast water treatment system because the inspector didn't wash his hands, especially these days with COVID. And last, but not least, the EPA VGP, unfortunately, is extremely tight on which methodologies are allowed to determine whether the system adheres to the standards. And that's not something easy and to take lightly. Make sure and check your service provider's methodologies and ask for that in detail, also for commissioning testing, because you want to avoid that he has to come back and that you pay again. In case there is a port state control check and he finds that there is that you've not stuck to these methodologies, actually you could risk fines. And my question to owners that do not ask for these types of process guarantees is it worth to save costs on this? Is it worth to save costs on not being compliant in the methodologies, or would you rather have it done well in one case? So in short, I think service providers should up their game, should start providing a better service to their clients. It does not necessarily have to cost more. And the risks of not doing it, I think, are very high. So, and the benefit that we have experienced with our customers is that it has allowed us to develop a very large network, particularly for the agri and ore trades and for the petrochemical trades, where almost anywhere in the world we can offer our services. And we have the standing agreement with our customers that they can always ask for even more exotic places if they accept us saying no sometimes in true Rotterdam fashion. So that's my my brief pitch. If you have any question, you can send us an email. You can check our website, and it's over to you, Sahan.
Paul, thank you very much for sharing your experience with the another very important aspects of the ballast water compliance, which is the sampling and analysis. I think we are on about on time with the agenda, so we have a good time available for questions. I saw there are a few questions coming from the participant, and we will come back to that one by one. So I will start, Paul, with you. Before my memory fades, you mentioned about the new requirements that you anticipate with the VIDA. As you mentioned, it is never easy to guess what is coming on. One thing for sure is that the new requirements, the VIDA bill says that the new requirement cannot be less onerous than the existing VGP 2013. So in the context of ballast water sampling and reporting, now the responsibility will go back to US Coast Guard. What is your take on what is you anticipate the new VGP sampling regime and the compliance?
If I look at it from like helicopter view, I see commissioning testing is relatively tight on sampling procedures, but relatively shallow. It can even determine microorganisms indicatively. VGP is not at all tight on sampling. Anybody can do it. There's no prescriptions. And then it's very tight on the methodologies by which you need to determine specific predefined chemical components. Actually, many of these tests are exclusively found in the United States. It is as if Mr. Trump wrote this regulation himself. So what I think will happen is probably there will be a bit more requirements on the sampling in VGP, and there will be an easing of the number of methodologies that can be used to determine specific components. And so it will be more easy to do these tests anywhere in the world. Does that answer your question? It doesn't necessarily mean that the thresholds that you have to adhere to will actually lower. They will probably get a little tighter. Does it answer your question, Sahan?
Yeah, thank you. Yeah, so what you are mentioning is that it would be more practicable for the ship owners as well as the service providers to comply with the new requirement.
Yes.
And that's what we both want, isn't it?
Yes. Yes. Well, for us, it is not so much a difference. So honestly, I don't think that once you have set up a network of procedures and laboratories and tests, actually, there shouldn't be a cost difference. But the nightmare of setting it up will become less, I think.
Yeah, okay. Thank you, Paul. Thanks. We'll go back to a few questions that, not few questions, there are about number of questions from the audience. I think I will go back to one of the questions coming from the audience, asking whether the difference of the filter types, which one is the more performance than the others. So this question is asked, I think I can ask this question from Nikos because Nikos has a different treatment system experience. The question, Nico, is there, the attendees is asking, in terms of efficiency and ease of cleaning and maintenance, what is the best filter available, whether it's a Filtrex, FilterSafe, or any other? Do you have any opinion, Nikos?
Hi, Sahan. Can you hear now?
Yeah, sure.
Yes, okay. Well, I think it's fair to say that all filters are performing well, but there are operational scenarios that even the best filter will encounter problems. So it is important not to miss the backflushing pump which was also mentioned by Optimaring. It may be missed. But be prepared that even the best filters cannot cope with very muddy waters in some rivers.
Yeah, so it's basically, I think, as you mentioned in your presentation, there are wide different conditions available in around the world, the ports, and I think the sediment load, what we used to call it, and not necessarily the amount of sediments, but also the particle size distribution can bring difficulties to any field at any time.
Yes, it is sometimes maybe helpful, but not easily to be achieved to actually go for a bigger capacity filter than it's needed. But it's not always available. This has to be worked out with the manufacturer, the chosen manufacturer. If, for example, your capacity is 100 and you go to a capacity for 120, if there is an available filter of that size approved to the system that you are going to select, maybe you have an advantage. You pay a bit more money, not big money, but if you can find this filter to couple with a preferred manufacturer, maybe it can help you to avoid some difficult operational scenarios.
Right. Okay. Thank you very much. Thanks, Nikos. So we'll go back to another question. Probably that question maybe aims at me. The attendees is asking, what is the main precondition for receiving the official extension to let the ship owner operator delay the system installation date from the class? I think I will answer this question, but if you have any opinion, please do share. First, I think what we need to mention is that if you have a date of installation to comply with the regulation D2, that exemption for the delay, you need to get it from the flag of the ship. The class will only act on behalf of them. As per you been asking whether there is a precondition, I think there is no, in my opinion, there is no precondition that you can set forward for receiving extension. But I would say that most of the flags that we have seen who has granted short-term extensions, that may be due to COVID situation or any other reasons. The condition is that the ship will be issued with the short-term certificate. That would be ranging from 1 month to 3 months to 6 months. And within that period, you need to install and you need to follow your procedure that you should have been followed. That is one of the main conditions. So none of the flags would give you a carte blanche extension that you can do it whenever you want. It's very time specific. It will be issued for a very short time period. Yeah, so let's go for another question. I think we'll go back to Shobit. In his presentation, he mentioned that the different aspects of the installation, because I think you must have a lot of experience in the understanding the capital expenditures, OPEX, and the time for the management. You mentioned very good point, Shobit. I wanted to touch upon that. That chart you have shown about the cost, and you have a bigger chunk of cost for the system and for the installation, but it not necessarily from the time wise, maybe a small cost items can take a lot of time. So when you're planning as a project manager for an installation, what kind of things that you will be considering, taking into account the cost and as well as the time schedule?
Yeah, thanks, Sahan, for highlighting this point. And as in Maersk, what we are working upon that for a vessel to prepare for a system installation, we expect close to an year of preparations, and the vessels which are going to start from for next year, suppose like in September 2021, we start our planning and evaluations and collecting the data from next year September onwards, as this will help us a lot of communications and feedback with the different stakeholders, especially the vessels, the superintendents, and all those involved. Because while designing, it's not only limited to the ballast water treatment system which is going to be modified, it's a lot of the pipelines and the operation systems going to be modified. Like they won't be able to do this by gravity, and so we need to find out the perfect solution so that the crew can also operate the system without the challenges. So we look somewhere around close to an year of preparations when we are installing the systems. I hope I am able to answer your questions.
Yes, thank you. So it's planning is everything, isn't it? This is not going to happen overnight. You need to plan in advance, and especially I think when coming into this next peak period, you might have to also consider the number of ships that may have your next IOPP renewal survey due.
Yeah,
Thank you,
right,
Shaukat.
Sahan, that's right. Yeah.
So we have another question. This is related to tankers. So I'm open for your suggestions. Maybe this is maybe more related to for you, Gregory. You mentioned about electric coordination system. So the question is, it's asking, tankers have their ballast water management system servicing the hazardous cargo block only where the ballast water management system is installed in the hazardous area. Full flow electric coordination systems store untreated saline water in an after peak tank to be used when in freshwater zones. So the question is, when you inject the untreated saline water, it is after the filter. So what happened to the above 50 micrometers in the saline water? Are they not killed? And was the biological efficacy by this method verified by the type approval entity? It's a very long question, Gregory. If you want, I can
Yes.
come back.
So can you just make the question shorter so I can understand it?
Yes. So what the attendee is asking is that when you have a full flow electric coordination system and you have saline water in your after peak tank, so you are going into a freshwater port, so you're going to use that saline water to mix with your EC system to bring up the salinity going into the system to comply with the type approval requirement.
Yeah.
So the question is, yes,
the system which I have studied is, as I said, the salinity is 0.85, which is means it's very near to the seawater, to the drinking water, which is 0.5. And when you come to tankers, as you said, I haven't come to this, I cannot answer what happened, let's say, if the tanker is in a lake, and he has to hold some salty water in order to increase the salinity to operate. So I do not know, but I have not come to this problem before because of the low salinity, which is 0.85.
Okay. Yes, Euron, please go ahead.
This is regarding a full flow system. So then you store some salt water in your tank in case you don't have enough salinity. These systems need slightly higher salinity, but this salt water is then used to produce your chlorine. So this will be really concentrated chlorine. So I think any organism that is above 50 micron will be killed by this pure chlorine, more or less, that you use to generate. So I think that it doesn't matter that it has not been filtered, it will be killed anyway.
If I may also chip in a 2 cent, Sahan, here, and,
yes, sure.
I happen to know the gentleman who asked the question. We have also come across type-approved systems, actually, that by design do not meet the discharge criteria for TRO. And then somehow, because of drawing issues and version issues that were not captured, by class, the type approval, or by the independent lab, the type approval was granted, but the system can actually never meet discharge limits. So if that is indirectly what this fine gentleman also refers to, this happens too. I guess it will be weeded out over time, but we have seen that in practice.
Okay, yeah. So in sampling, you would see these situations happens. Yeah, yeah. So that's a very good example that not all approvals are perfect, and I think that's one of the reasons that the IMO has started the experience building phase to see how the systems perform. Maybe it's a design, maybe during type approval, maybe installation. There are many things can go during the life cycle of a ship. So the idea is to capture where the failure happens and where it actually taking more places that we wanted to focus on. I think we probably have answered that question. So let's move on to another question. Again, we have some question regarding the filters. I think we have answered about the questions on the filter. I would like to ask from Urian mentioned in his presentation, and there are a couple of questions also I have seen regarding the different modes of operation of the UV ballast water management system. So that's one question specifically asked, I think is more or less applicable to Urian in his presentation. They're asking about that when you have two modes of operation, one for US Coast Guard, one for IMO, that means you need to know when you are ballasting that which mode to be selected. For example, if you have a ship on a spot market, you don't know where you're going. So in that situation, what is the advice from the manufacturer?
Yeah, so if you have chosen to ballast in IMO mode and then you learn that your next port of destination is in the US, then what you have to do is exchange officially. So then during your voyage, you will exchange your tanks and then retreat with in the IMO mode. So yeah, it's an operational kind of question, but normally you would know, or at least you would hope that you know that when your next port is going to be US. And in case you made a mistake, then yeah, you retreat. You can of course choose, like we might go to the US, so let's treat in US mode. That's always possible because that's of course allowed in IMO as well. So yeah, so it is not possible to automate, or I mean, if the crew doesn't even know, then the system is definitely not going to know.
Yeah, so if you started on a US Coast Guard mode, then you don't have a problem. Even if you are going into IMO, you are compliant because it's high power. Yeah. Otherwise, your suggestion is that maybe they need to do a exchange, or maybe they can, if they have another tank, highly unlikely, but if you have an empty tank, you can transfer and maybe started running on the US Coast Guard mode again, treatment, maybe following discharge.
Yes. And of course, remember that the US, it's a discharge mode. So if you are going there to bring any cargo, then you will be taking ballast water in. But then, of course, you would know it beforehand. So that is, yeah, not relevant in this case. But anyway, so yeah.
Yeah. Okay. Thanks, Urian. We'll have a few more quick questions. I think we can go into the.
Can I add one thing on the filter, Sahan,
Sure.
just briefly? So if you want to make sure that your filter doesn't get clogged, I see there's still some more questions on that in the Q&A. Ask your supplier whether it's been tested to 1,000 micrograms per liter, which a normal test facility should be able to do. And so that prevents clogging even for very murky, dirty waters. Milligrams, sorry.
So that must be additional test to the type approval program for US Coast Guard and IMO.
It is included with us. So if your system is type approved by us, it's a fairly standard, although not so common way of testing filters.
Okay. Yeah. Thank you for that. Yeah. We have another question. Yeah, there are a lot of question is about filters and sediments. There's another question about ballast water regulation of inland towing vessels. Please, again, if you wanted to have an opinion, you can share. I think this is referring to the vessels maybe specifically running within one jurisdiction. If that's the case, even if it is an inland towing vessel, then you may not have to comply with the convention requirement. But if this is a ocean-going vessel, happen to be in the inland waters, depending on the towing, what is the towing vessel is, that whether it's a barge, whether it's a dump barge, there are requirements in the IMO, and more or less what they're saying is that they need to either meet with the regulation D2 standard or equivalent. There are a lot of debates about what could be the equivalent. The best thing is to actually have a discussion with the flag, because they are the ones who can dictate the terms and conditions for your ship. And also you need to get to know about the other country where the inland waterways is, what is the requirement of that port state. We have another question. I'm not quite sure who can answer this, so I will send it to the group. Is asking about the global market share of a ballast water treatment system in Asia. So the question is, can we consider the doubling growth of Asian market by looking at a considerable demand? I think this is probably be for manufacturers and installations, if you wanted to answer.
I have to admit that I don't fully understand the question.
Well, that makes two of us, Yurin. The question is saying that, I think what he's trying to say is that the ballast water market share in Asia is increasing. It's probably the ship owners or ship installation, or could be the installation, because we have all the yards in majority of the yards in Asia. Well, the question is that, looking at this growth, what they're asking is that can they be considered this growth is being sustainable, and do you have plans to meet this growth in Asia? Can you provide services as requested?
Yeah. Well, the model of Optimarine is very scalable. So, I mean, there's of course a limit. The sky is the limit, but that's of course never true. And but yes, we can handle quite a bit of growth, and also in terms of service, we have a large service network that can also, you know, further expand whenever needed. So yeah.
Okay, thanks. So there's another question regarding the environmental impact. I think probably Paul, this is maybe fit for your resume. The question is asking, periodic cleaning may be important to maintain the performance of ballast water treatment system. What environmental conditions will impact the frequency of cleaning?
Yeah, I think it has to do with the water quality upon ballasting, I suppose.
Yes.
So where have you last loaded? Where have you last discharged? Where have you ballasted and deballasted? I think it also depends on the type of systems. And I think if the question relates to the filters and the maintenance of the filters, then I think we discussed that a bit already, didn't we, Sahan?
Yes, I think probably they're talking about maybe a UV system. You will probably have to do a CIP cleaning.
Yeah.
So as you mentioned, it's all depending on the inlet water quality, and also probably how long you have kept the system idle, maybe not using.
I think here Nikolas actually, during the pre-discussion, he mentioned the most important rule for ballast water treatment systems. Nikolas, you mentioned use it. When you have it, use it. Don't just let it sit, use it. That's the best. So idle ballast water, that is going to cause problems sooner or later. Was your point, Nikolas?
Yeah, indeed.
So as a second question to that, Nikolas or Shobit, do you have experience that because now we have seen this with the compliance schedule, ship may have installed a treatment system, but they don't necessarily have to use it because their compliance schedule is maybe next year or year after. So in that situation, what is the practice in your fleets? Are you constantly using the treatment system that maybe you have comply with the D2 requirements beforehand, or you use it periodically, or you don't use it at all until the date of the compliance?
Yes, and that's a very good question, and it's a very valid at this point of time. But from our side to the vessels, the instructions are to use the systems regularly during the port operations. Whenever they have to do the ballasting or deballasting operations, it has to be through the treatment systems until unless they are facing any challenges with the systems. So, and it's a very sharp focus we have on this parameters, because this is the time, not it's not only gives us a confidence on the ballast water treatment systems operation, but also gives us a good ample amount of training for the crew on board and their experience with the systems when they have to use it. And on a regular basis, in order to observe the performance of the treatment systems, what we have done as a ship owner to that we are requesting the vessels to report the running hours of the ballast water treatment system into the PMS systems on a monthly basis, and remotely we are monitoring the operational hours of the treatment systems, and on time to time basis we are getting the reports from the vessels through the treatment systems panels. So that's how we are keeping a track that the vessels are able to utilize it, and it's a good feedback from the vessels, or I can say the positive feedback we are getting it from the vessels with regards to the system operations. And a good questions are also coming up, which we are very happy to answer them with the help of definitely our makers, because they are the experts, and they are very, very helpful to us in supporting it.
Thanks, Obit.
Thank you.
Nikos, do you have experience with your fleet?
Yes. The policy is to run the systems. I want, however, to comment that if a system fails for a reason and the repair takes some time, then people will experience that it will be very difficult sometimes to restart the system. Also, I have to mention that not all makers are so helpful with the customers. This is a key factor when selecting a system, to have as much better global support 24/7.
Yeah.
So.
Thank you. So, so it's the experience is that if you install it, use it. And
yes.
yeah, that's a very good, I think, advice coming from you as one of the biggest ship owners. We have another question regarding electrochlorination system. So the question asking is that electrolytic chlorination unit, I think they're probably talking about the chlorination system in general, bear a risk of catastrophic failure. What can be offered for the solution or to eliminate the risk? To make it understand, I think what they probably be asking about the production of hydrogen as a byproduct of electrochlorination system, and how the risk of hydrogen can be minimized or averted. Before I send it back to the group to answer, I can say two things about it. One is that the side stream electrocoordination system, all of them would have what they call is a degas equipment to effectively remove the hydrogen produced before it's going into the ballast tank. And that is a more common practice with the side stream electrocoordination system. So do you have any opinion how the other electrocoordination system manage this risk of hydrogen going into their tank and subsequently having a catastrophic failure? Anybody wants to comment?
Okay, so I will start by actually asking the panelists. We have a lady representing a maker here, and maybe she can put some input whether the UV system creates nitrogen during operation.
No, UV system does not create any hydrogen gas or other fumes. There's no. I think there are some ions that can be a byproduct, like bromide and things like that, but they are not. They are more biocides. They're not explosive or anything like that.
Okay. I think what Sahan says about the side streaming is the case here. I haven't heard any serious problems in the recent years. In the very beginning, there was a lot of concern. I'm talking about 10, 12 years ago when we started ballast water installations on new buildings in Korea. There were a lot of concerns at that time and real scale measurements of hydrogen. Later on, these were taken more, I believe, more seriously by the classification societies and the makers. There are risk assessments, there are measurements. However, I want to put a statement here, since I'm also an ex-Lloyd's guy, that not all certificates count the same. We must be very careful when we're selecting a system and who is approving the system and how the system is approved and under what conditions.
Yeah.
Here.
Thank you, Nikolas. Yeah.
Can I just add that if it's not just about hydrogen, but for example, also about corrosiveness of high chlorine waters, like in scrubbers you have with the acidity, then I expect that at some moment there will also be all kinds of non-destructive testing on key pipes and key piping that is going to be required just to prevent I think some of the movies that you can download on YouTube actually that show huge water explosions in engine rooms. Yeah, so I guess that will come too, but so far I agree with Nikolas. I haven't really heard about it recently, honestly.
Yeah, so from the class perspective, I mean, I think I can share some thoughts about it, that the approach is that you have a treatment system, and when you're type approving it, there will be a risk assessment done for the G9 purposes, and there will be, if it is an active substances, especially in LR class ships, we ask the manufacturer to submit a risk assessment considering the installation scenarios. So it's not just specific to the system as a standalone, but also looking in few scenarios of installation, maybe on a tanker, chemical ships, on deck, in the engine room. And with that risk assessment, you can actually make a determination, assess what kind of a probability that there will be a severity of that risk, and then you take appropriate action. I think, as you guys also mentioned, that now the class rules have developed in the IAX UR. Also, now there is a second revision going on, the installation of ballast water treatment system with more restrictive requirement of where you can install a system, how the venting should be aligned, and what type of material, and how the ventilation requirement for that particular ballast water room or engine room should be provided with, and the fire and safety requirements. So I think I would agree that that we are getting into a more understand on the systems and how it behave. With that understanding is helping us to move into a very high safety records, probably than it used to be. Yeah. So we have another question that is also regarding the safety of the ships. The question is asking, in the process of flow-through method of ballast water treatment system, how the overflow tank with air pipes could be managed. I think what, if I make it the correction, the flow-through method is relating with the regulation D1 ballast water exchange standard. But it's a very good question. The question is asking, when you are overflowing the tank through an air pipe, how this could be managed. Will it negatively affect? Maybe we're asking about whether it's negatively affect the air pipe itself. Do you have experience when your ships were doing ballast water exchange through the air pipe? How well those air pipes were constructed and behaved for this operation, which is in a way the air pipes and the ball valves are not meant for dispersing water, but that is only meant for constructing for dispersing air. Shobit, do you have any experience?
No, unfortunately not in this case. Haven't had any.
Yeah. So if you, I think again, I can answer for this one because I have seen. Nikos, yeah.
Yeah,
please.
actually, you don't. You never flow through the air pipes. Even class will not allow you to do that. You have to open manholes and flow through the manholes. Okay. First, you will damage their pipes. Secondly, not allowed because you will create a pressure. So you open the manhole and you do the flow through.
Yeah. Thanks, Nikos. I think that's what I was going to say, that it is actually the good practice and how the crew operate the ballast water exchange. I have seen pictures of air pipes that's been used for the flow through, and it's fair to say that those are not constructed for the purpose, and you will definitely damage it. So the advice is that if you want to do the flow through, you have to do it through the manhole. You have to open that few bolts and open the manhole rather than letting it go through with the air pipe. Thanks, Nikos. We have another question from the audience. The question asks about with the implementation of effective energy policies, I think probably they're talking about the greenhouse gas emissions and meaning of renewables. Is there a possibility to use thermal techniques of ballast water treatment system? Do you have any opinion on thermal systems?
Shobit, was it not on your slide?
What is thermal?
Yeah,
thermal?
yeah. Through then there is, as I know, there is a Danish ballast water treatment system maker, Bawat, who is using the excess heat from the ships to treat the systems. And it could be could be used on the tankers while they are, or to the economizers. The excess heat are used for the treatment of the system. And as far as I know, their systems is also approved from the IMO and the USCG as well. Yeah.
Yeah. So I think that's the answer for that question. That the Bawat systems, for example, they use the excess heat from the engine. And there are ways that you can actually reduce your CO2 footprint. That is a very timely discussion right now, even at the IMO with the greenhouse emission gases. We are coming into a conclusion, but there was a question that runs in my mind for the last couple of years. I think we probably can conclude with your opinion on that question. You can see that where the whole industry, including the IMO, is heading into energy saving, greenhouse gas emission, reducing the CO2, more greener path. At the same time, the ships have to install, in our subject is a ballast water treatment system, or maybe a scrubber, equipment that actually consume more power. So are we gaining a net value here? Are we doing best for environment? How we can balance the need for reducing carbon footprint or the energy requirement versus meeting ballast water regulation, for example. I will ask your opinion one by one, and we can conclude the conference today. Do you want to start, Shobit?
Yes, and that's a very good question. I can say that's definitely $1 million question for today when it regards to the ballast water treatment system industry. And definitely it's a catch-22 situations, because on one hand we are trying to save on the power consumptions and CO2 emissions, but on the other hand we are burning them to save the environment as well for the oceans. So what I would like to add on here, that and the current situations where we are having D1 exchange methods, where we are running the ballast pumps additionally to either do the ballast exchange, the flow through methods, or through the exchange methods. We are still utilizing those energies. I have not done that evaluation that how much it is in comparison to that, but yes, we are doing in that manner, and some work to prevent these microorganisms flowing around the world and affecting the others. So yeah, that's from my side. Yeah.
I can see Gregory next in my screen. Hi, Gregory, you are on mute.
Yes, now you can hear me now?
Yeah, please.
Yes, water ballast system definitely is improving the environment, definitely is worth the money spent, and probably you should have done it earlier, because even in Mediterranean now we have seen some funny species that never used to be before, or some poison fishes. So I believe it's worth the money spent, and we're doing a good job to the environment.
Okay, Gregory, thank you very much. Nikos, you are next.
I think the whole approach, as you know, from IMO is not holistic. So we are doing something to help the environment in one way, and we're damaging the other way. This is how IMO is working, and at this very moment, we just have to follow. Unless IMO change their approach to more holistic for the whole environment, including air and sea, we will just continue spending energy in one way, wasting in the other way. So that's the reality.
Yeah. Okay, Nikos, thank you very much. We have, oh, sorry, my screen went blank now. I think we have Urian next.
Yes, it's not a question you can really answer. It's a trade-off. So we choose to burn fuel to, stop spreading of invasive species that also cause environmental damage. So yeah, I cannot answer which is better or which is less bad.
But we both need both. That's what you.
Yeah, exactly. You should try to do it using as little power as possible, where UV is, of course, not really on the low end of power consumption, unfortunately, but maybe on other environmental issues. But yeah, we have to do something, I think.
Yep. Thanks, Jürgen. Paul, finally, it's back to you for your wise opinion.
Yeah.
I hope that you have an answer.
Well, my answer is we don't have a choice, really. Biodiversity is the next thing after climate change. There is no home run in shipping. It's all incremental improvements. And unfortunately, we have to do it in a sprint because we're late and we have to catch up with many other industries. So my point would be is let's do this ballast water treatment right. Let's do the scrubbers and the sulfur cap right, and then look for all the other plenty of opportunities to reduce the fuel bill, because there we have a lot of way to go still, particularly for chartered tonnage that is now often steered and directed on noon reports only. So perhaps ballast water treatment systems use a little more energy than not operating them. We don't have a choice, and we should just find other ways to become more efficient fast, because we're late. We don't have a lot of time left. And I say this on behalf of my daughters.
Thank you, Paul. Thank you very much for all the panelists today. I think we went a little bit over the time limit, but I think it's very worth spending that time to pick your brains. You have different experience and knowledge and skills on the different as a different stakeholders of this ballast water installation comply with the convention. Let me take this opportunity to thank BS Group for inviting all of us for this conference, and all the attendees for this conference for staying with us for the last close to 2 hours and sharing their concerns and listening to us. Thank you. I hope you will find a better future with all these environment regulation in place. So stay safe. Thank you for joining. Thanks for now. Bye.
Thank you. Thank you very much.
Moderating.
Bye, Sahan. Bye.